Welcome, everyone. Good day to you from wherever you are watching in the world. Maybe you can put in the chat where you're watching us from. I am Nancy Regan, and I am joined by Mark Horton and Graham Stephen and Chris James. Jesus Safonte is not with us today, but he is part of the RCM Certification Committee. We are the International Reliability-Centered Maintenance Certification Committee, and we are dedicated to making sure you get the best out of your RCM analyses. And today we are joining you live. Chris James, one of our examiners, is going to talk today about RCM or why RCM is not just about maintenance. And so if you have any questions as we go, as Chris shares his thoughts with us today, please do put them in the chat, any questions or comments, and we will get to them. So allow me to introduce you to Chris. Chris has been implementing reliability-centered maintenance for over 25 years. He worked directly for 11 years with the late John Mowbray, founder of Alidon and the author of the book RCM 2. He helped John to develop training materials and part of the content in John's book. He has been very generous with me with his knowledge over the years and has helped me a great deal. So we are in for a big treat. So Chris, I'm going to turn it over to you so you can share with us why RCM is not just about maintenance.
Okay, thank you, Nancy. So you can all hear me? You can hear me, Nancy?
Yes, we can hear you and we can see your slides.
Okay. Okay, so as Nancy said, I think there's, please put it in the feed your comments, and we'll have time hopefully at the end to discuss. This is not going to take an hour. Now, I believe I said in a previous call that one thing that I like about the SAE RCM standard JA 1011 is that it's very brief, it's very concise. It doesn't have a lot of words in. And now this doesn't mean that the committee that wrote the standard were lazy. Because it's also a very comprehensive standard. It covers all the bases. And paradoxically, if you think about it, it's actually more difficult to write a short document that is comprehensive than to write a long one and simply throw loads of words down. And I think I might also have mentioned in a previous call, one of my favorite quotes really was from Mark Twain, an American author who I believe once wrote, I'm sorry I didn't have time to write a short letter, so I wrote a long one instead. And you know, the RCM standard really seems to reflect the teachings of Mark Twain as well, really, in that respect. But what that means really is that also there is often a lot of thought and a lot of meaning, a lot of hidden meaning in some of the words, because a lot of the words in the standard are very, very highly developed, and a lot of thought has gone into them. And if you read it quickly and superficially, you might not actually realize the significance of those words. And that's something I want to explore today in one area, which actually is quite important. It actually goes to something quite fundamental, which is, you know, what actually is RCM. So hopefully that's now moved on. So this is something that I got. This is not from the standard. This is something I got from Google. And when I typed in what is reliability-centered maintenance, and this came up very high on the list, and I shall read it to you now. So reliability-centered maintenance is a corporate level maintenance strategy that is implemented to optimize the maintenance program of a company or facility. The final result of an RCM program is the implementation of a specific maintenance strategy on each of the assets of the facility. The maintenance strategies are optimized so that the production of the plant is maintained using cost-effective maintenance techniques. Now, I would actually have a problem with that because, in my view, anybody that reads that statement would be forgiven for thinking that RCM is just about maintenance, because it seems to just talk about maintenance. And the point that I'd like to make really in this session is that RCM, of course, it is about maintenance, but it's about more than maintenance. It's not just about maintenance. And if you just look at it as a program for deciding what maintenance to do, you're missing a whole load of things. So I'm going to start with a bit of theory from the late, great John Mowbray, and then I'm going to go on to a few examples, and I'm sure other members of the committee will have lots of other examples they will add as well. So Mowbray tells us that any asset has two standards of performance: what the asset can do, its initial capability, and what we want the asset to do, its desired performance. And maintenance can only raise the performance of the asset up to its initial capability. So if you've got an asset for which the want is above the can, it will be in a failed state. And of course, maintenance will often have to pick up the pieces to deal with those failures. But fundamentally, no amount of maintenance is going to increase the performance of the asset beyond what it was initially capable of doing. Okay, so the definition of a failed state is when the want is above the can, when the desired performance is above the initial capability. It's very simple, a very simple model, actually a little bit embarrassing, isn't it? A little bit insulting that you come along here and listen to me something that tells you something that's this blatantly obvious. But it's actually a very powerful model because it's a good way of understanding and considering the different ways that things can get into a failed state. So a few more points I'd just like to make about this model really is that there's a lot of pressure, isn't there, pushing the cans down. Mowbray said that you should have a gap between the can and the want, which he called the zone of maintainability. And there's a lot of pressure pushing the can down particularly at the design stage. Everybody wants to save some money. Everybody's under great pressure of time. Everybody wants to value engineer, don't they? And consequently, quite often, the capability of the equipment in lots of different ways is being pushed down. And there's also a lot of pressure pushing the want up. Particularly, later on during operations, we always want a little bit more from the asset. And we're not just talking about absolute performance of an asset. We may be talking about things like accuracy or tolerances or the environment in which the equipment operates. But often we want more, don't we? And operations want more. And another point to bear in mind really with this is that we're not just talking about performance standards in terms of absolute performance of the whole asset. We've got cans and wants all over the place for the asset as a whole, for systems and subsystems and components in the equipment as well. And we've got it, as I say, for all sorts of different parameters, depending on the context. And so it could be absolute performance, or it could be tolerances, or it could be the environment in which something operates. And if you think about how equipment comes into being, the design process, quite often designers do a very good job, but even at the design stage, things are sometimes a bit suboptimal, aren't they? As I say, everybody is under great pressure to do things quickly, to get their job done and move on, and to save time and to save cost. And often things aren't well communicated. You've got different entities, different organizations doing different parts of the design process. Not always well communicated, not always well documented, and of course things can change. And so, if we think about it in these terms, it's quite, you can understand the different ways that something can get into a failed state. And there are perhaps four categories. You could put them into four categories of reasons why want can be above can, why equipment can be in a failed state. And the first category of this would be the well-known mechanisms of deterioration, things like erosion and fatigue and corrosion, lack of lubrication, build-up of dirt or disassembly, things that cause the capability of an asset to fall below what we want it to do, which causes it then to be in a failed state. But that is not all, because also things can change, and as I say, we might want more from the asset, or we might want it to work more accurately or in a different environment. And in other words, situations in which the want can rise above the can. And maybe this happens deliberately. We deliberately push the equipment beyond what it was originally intended to do, or maybe it happens unintentionally at times. We don't really realize, or maybe, of course, conditions may change. And then there's another category of failures, which are those that have been the equipment hasn't really been fit for purpose right from the beginning, perhaps because of design, perhaps because of the way it was installed, or perhaps because of procurement issues, where want is above the can right from the beginning. And then we have a fourth category of failures, perhaps, that may cause the can to fall below the want because of the things that people do. Because any equipment really doesn't really operate in isolation, does it? It's part of a wider system that often includes people, including operations and maintenance. And do operators always operate the equipment in the same way? Do maintainers always do their work in the same way? Are those procedures always are they well defined? Are they precise? Are they clear enough? Do people have the competence to do all the things that they're supposed to do, etc., etc.? There's a whole bunch of reasons why things can fail because of the things that people can do, okay, that can cause failure. And you know, I don't know about you, but in my experience of looking at failures over the past 30 odd years, I've seen all of these. And and I got some examples coming up really, but you know, in my view, things can fail for all of these reasons in virtually all cases. And if we then follow this through into what therefore you should do about it, if we've got deterioration, you know, you can manage deterioration through maintenance. You know, Mowbray said that maintenance is about putting energy into a system to keep the can above the want. Which is fine. But of course, if things have changed because of the way things are operated, maintenance may have to pick up the pieces. But no amount of maintenance fundamentally can solve that. We need then perhaps to look at the way we're operating the equipment, or perhaps go back to the design to do something, to change something which is not maintenance, to improve the capability of the equipment. And then if we've got a design flaw from the beginning, obviously the thing we need to do to that is to improve that. And if we have human factors that can cause failure, then the way to deal with these is to look at the way we operate and maintain the equipment, and maybe look at the procedures and the training within which people work. And maybe also sometimes we can also consider the design. I think, don't the Japanese call it pokiyoki, the design of equipment to minimize the risk of human error? Okay, so you know, for these different causes of failures, we have different outputs, and they are clearly not just about maintenance, is it? And so, really, from a theoretical point of view, reliability is not just about maintenance. Maintenance has got a big part to play in reliability, but reliability is not just about maintenance. And actually, I do remember John Mowbray saying that in some ways the M in RCM is a little bit of a handicap, because it does suggest, and some people may believe, that RCM is about reliability-centered maintenance, whereas I would prefer to say, well, perhaps we should be putting more of the emphasis on the R, which is the reliability bit. So moving on now to some examples. So I worked for a while for a large consulting company. And you know, a big thing about what we did was the big presentation at the end. And I did lots of RCM studies on for this company. And you know, one thing that I was always asked to do for these presentations at the end, to count up the number of tasks, the number of recommendations. And I always sort of objected to this a little bit. I couldn't really see the value of doing so, but there was a little bit of value. And so this is quite a large study that I did, and a typical sort of set of recommendations. And so from this particular study, there were 178 recommendations. It is quite, you know, moving down the list here. It's quite valid, of course, under the right circumstances for some failure modes to have a strategy of no scheduled maintenance. That's perfectly valid under the right circumstances. When it comes to the proactive maintenance, there was a bunch of proactive maintenance, you know, cyclic maintenance tasks, and the vast majority of those are condition-based maintenance, because as we know, RCM favors condition-based maintenance. But there's also a number of scheduled traditional PM, scheduled restorations and overhauls, and a number of failure finding tasks. And the number of failure finding tasks might obviously be influenced by the nature of the asset, the number of instruments you've got, and how much maintenance you need to do on those. But what I also came up with on this particular study was actually quite a few one-off changes. And I call them one-off changes because the term redesign, which is sometimes used, is actually a little bit misleading, because it sort of suggests that we're just talking about physical redesign. And I think one-off changes is the better way of describing it. And you know, this included some of those other issues that were mentioned earlier, you know, things like procedures and training, as well as physical design. And the point about physical design changes is that it sort of implies like a large scale expensive, large-scale physical redesign of the asset as a whole. Quite often these could be design changes at quite a low level and at the components level to build the resilience and to strengthen the equipment. Okay, we're not necessarily talking about an expensive high-level redesign, all right? And we're not. Now, this particular client, it was a big project that we were doing, and they had another RCM consultant on site, and we were given their analysis to review. So we didn't obtain this unethically. We didn't obtain it through subterfuge. We were given it by the client, and they asked us for our comments. Now, this particular study, this was a similar exercise that was done on a competitor's analysis. Now, this person, who shall remain nameless, was very active and is still active in the RCM market. You see, been doing it a long time, and you still see this person operating and selling the services. But what was interesting is that they had this particular study, a different study that this consultant had done, the competitor consultant, just had maintenance. They just provided a maintenance solution. So in my view, they missed lots of opportunities to improve the reliability because they just focused on maintenance. Okay. To their credit, they, at least where they did have maintenance, they had a high proportion of condition-based maintenance, which is good. But another interesting feature of the analysis was that actually they had a very large number of recommendations. It's almost as if they tried to get paid by the number of failure modes that they generated, because they've done it quite inefficiently as well. But that's another issue. But so this was proof to me that there are lots of people out there that believe that RCM is just about maintenance, because this was a consultant selling RCM services that had come up with something like this. Okay, so I'm going to move on now to a few examples. I could give you three examples from different industries. So this is one that I did in aluminium recycling. I think you call it aluminum, don't you, in the US? But this is aluminium recycling. So this particular plant in the north of England, what they did is they took a few million used beer cans, and typical output from a weekend from a city in the north of England. Took a few million beer cans, they melted them down to create these slabs of aluminium for recycling purposes, and in an aluminium furnace. And they had a pump that was used in the bottom of the furnace to circulate the molten aluminium. And the pump was unreliable. And the sister plant in Germany had a much more reliable pump. And I went in as a consultant to try and help them use RCM to improve the reliability. And what was interesting is that virtually all of the failure modes for that particular study were about things that could not be addressed by cyclic maintenance. They're about process and procedures and practices. So, for example, the operators actually cleaned the pumps using rods, and they did so too late because the pumps got slag on them, got built up of slag. They did so too late. They did so too aggressively, and they damaged the pumps. Now, these pumps are quite simple. They're made from sintered carbon. Now, when the pumps are assembled, of course, if they've got any moisture in them, and then they go in the furnace, you're going to get water vaporizing very rapidly, or moisture vaporizing rapidly, which would expand and could crack the pump and damage it. So one thing that was very important when they assembled the pump was to bake the components in an oven. Now, the oven had no temperature indicator, it had no timer, there was no procedure for doing it, and different people behaved in different ways. Some people put the components in the oven for 5 minutes, some people put them in for 5 hours. There was no consistency in the way that they assembled or treated the components before assembly. And also in stores, so this was actually quite, it looked quite a robust pump, but it was actually quite brittle. And when these components came in, they carried them around in stores put them in stores on a forklift truck. They bounced them around. They stored them on top of each other. There were lots of failure modes related to the way that the components were handled before they used it. Now, if I just focused on cyclic maintenance for the pump, I wouldn't have delivered anything for this particular client, and the project would have been a failure. But by looking more broadly at the little bit at the process around it, and some of these practices that were taking place, we were able to come up with a very successful analysis that certainly delivered the goods. So another example, this is from the oil industry. This is a compressor that it was a centrifugal compressor compressing gas that went into a power station, and the power station tripped due to lack of gas a few times. So it was actually politically charged and very because the minister owned the power company and he wanted to know what was going on. So it was a very high pressure analysis, and we came out with lots of recommendations. But one of the key recommendations was actually about operator procedure. And when I did these studies, I also had a consultant with me who was able to, a bright young consultant who was able to go along and do some data analysis and to go and speak to people to feed back information that would reinforce the RCM study. So it was very, very useful. And what he did is he looked at the performance of different shifts, and different shifts had different success rates at starting up and at dealing with trips. And the fact that different shifts performed in different ways shows that there was good practice and there was bad practice. And that's an opportunity, is it not, for identifying good practice and spreading good practice. And also some quotes at the bottom there. It was very clear that there was a lot in terms of startup that was not working as it should. And so, we did have lots of recommendations from this project, but one of the big areas of recommendations were about procedures for the operators in terms of how they started up and what they did if they had a trip. Because actually, if there was quite a lot of gas stored in the pipe, and they had quite a lot of time if they had a trip to do something, to think about it before they rushed into doing the wrong thing. Okay, so. And the final example I would give is again from the oil industry. This was a deep water disposal pump, and this was actually quite an old oil well that had a high water cut. So for every part of oil that was produced, 4 parts of water were produced. And fortunately, it wasn't nice, clean water. It was dirty and saline, and you couldn't just. You needed to be disposed of, and the way that they disposed of the water was they pumped it back under the ground in these deep water disposal pumps. And if they couldn't get rid of the water, they had to stop producing oil because it was needed to be disposed of underground. And they had problems of reliability, and it was quite a big analysis. It included all the systems around the pump, but what was very interesting really to me about this was the number of recommendations and the breadth of the recommendations about things that were not just about cyclic maintenance. Okay, so I've color coded them according to some of those different categories, but we've got here some issues of design, some issues of training, procedures and competence, and also of can rising above want because of operating parameters. And I think it's quite clear, if you want to do this and you want to do a proper analysis, you need to know what really happens. You couldn't go making these sorts of things up. And in order to do a proper RCM analysis, you really need to have, of course, the people that know the asset best, who know what really happens. And also you need to do this in a environment that's non-adversarial. It's not about pointing fingers, but if you could do that, if you can get the right people who speak freely, and quite often there's a lot of very valuable information that all contributes to improving the reliability. But in this situation, there are issues of competence, there are issues of maintainability, issues of design that cause risk or that cause vulnerability. there were components that weren't on the system, for example, quite a small thing, but it can contribute to the levels of risk. And there's a tendency, perhaps because of this thing about the wrong springs, for people to be tempted to use the wrong springs with the reliability impact that could have downstream. And although there's only one issue in this example, this is just selected examples, by the way, this isn't the whole study, but although there's only one example here of want rising above can, rather, this is probably one of the biggest recommendations. And the Sume coated cartridges, this was the sorts of pump, and you can get different coatings on the cartridges. And what had happened over the years is that the water that the pumps had to deal with had changed its characteristics. It had a lot more particles in, and it was a lot more aggressive. And the cartridges that the pumps were coated with, the internals of the pumps, were not sufficiently robust. And so, the want had risen above the can in terms of the levels of contaminants they had to deal with. But, a big recommendation was to change the coating. Okay, so I could go on. There are many more examples I could give, but just to wrap it all up, this is the definition of RCM from the SAE standard. Okay, so what the SAE standard says is that reliability-centered maintenance is a specific process used to identify the policies which must be implemented to manage the failure modes which could cause the functional failure of any physical asset in a given operational context. And it also goes on to say that the failure modes should include any event or process that is likely to cause a functional failure, including design defects and human errors caused by operations and maintenance. Unless these events are being sufficiently addressed by processes apart from RCM. So, maybe in some environments like aviation that just focus on maintenance because they have other, in RCM, because they've got other processes that are looking for, looking at design and human factors. Okay, but some important words there from the SAE standard. And the final slide I have here is actually from a quote from the original Nolan and Heat report, just to reinforce this. For most complex items, there is no form of scheduled maintenance that can safeguard operational reliability, no matter how often or how intensively it is performed. So in other words, it's not just about maintenance. So food for thought, hopefully. I don't know if any of you got any agree or disagree. It'd be good to hear from you. Thank you very much.
Chris, that was an incredible presentation. It's so eye-opening. And when you first started to talk, you said that when you were talking about can versus want, that it's a blatantly obvious topic, and it is, right? But I will echo what you said. In my experience with analyses that I've facilitated, I've found similar results. And what I think is, it's such an obvious topic. It's such a simple concept that it's often overlooked because in our industry, really in any industry, as human beings, I think we often look for the complex. And so the simple is often overlooked. And I think that happens with want rising above can a lot. And that can be a cause of chronic failure. So people are all looking up here for why is this, why am I getting this chronic unreliability, where the answer could be right there under our noses.
One thing Mowbray always said is that it's not always rocket science. It's often the simple things.
The odd thing is, Chris, that sometimes people seem to know the answer already. They will tell you that they have. One example, it's really simple, was a bearing alignment problem. They knew that their bearings were failing because of alignment, but they just didn't have the tools, and that was the complaint of the maintainers. They didn't have the tools to do it.
Yeah.
But when you come into it, you're thinking, well, well, why don't you get the tools you need? But yeah, I mean, that was absolutely fantastic presentation, Chris. You don't often see all that in one place. I think that's what's so powerful about it. Can I ask you a question, Chris? I'm really dying to get an answer to this one, because you presented that contrast between the analysis that you'd produced and one from a competitor, and very kindly didn't mention who the competitor was.
Are you going to may need to ask me that question offline then?
No, I wasn't going to, Chris. No, I was kind of going to ask the question of, at what point do you tend to realize that this is a site or a customer or a set of individuals that are going to have a problem with extending beyond their current really restricted definition of maintenance? And then, since you're the absolutely archetypal diplomat, Chris, how do you tend to handle it? You know, how do you get people gently to change their view of what maintenance is?
Yeah, good. Well, I think it always helps, you know, as an engineer, just to talk about the equipment really, and you can argue in terms of failure modes really, and then the facts of the failure modes really. So I think, you know, when we went back to the client, we then presented the failure modes that we had, which identified the things that the group had come up with, because obviously this is, you know, you get this information from the team, you go back and you present what their people have come up with. That is not just about maintenance, and then you just point out, you know, therefore, I'm not pointing any fingers here, therefore, but something is missing, isn't it? You've missed things. So yes, you have to go back to the failure mode. Go back to the failure modes really. There's always an answer in RCM.
Thanks.
Okay, and Chris, I have a question. You mentioned when you said something like when you ask the right people. Could you elaborate on that?
Okay, so you know, we have a team. It's a team-based approach, isn't it? You know, we don't just do one thing. You don't just do the study on your own. Nobody knows it. No one person knows everything there is to know about the asset, and therefore we want the people that know the asset best in the team, who know what really happens, and this would include those from operations and good operators. There are some very good operators out there, aren't there? There are some bad operators, but also some very good, like everybody, you get the good and the bad, but good operators are very can be very good. And if you ask them, you know, about what really happens, they can come up with all sorts of gems really. And obviously also you need again people from maintenance that know what really happens, and a key thing about it, of course, as I think I said, is that it needs to be done in a non-adversarial way. You know, it's not about pointing fingers, but you need to ask the people about what really happens, and you know, in what do they do that's wrong, but what do they think that other people might be doing that could be better? You know, just ask it in a diplomatic way. And of course, maybe you also want people from the design, if you design stage, if you can get access to such people. Not always possible, of course.
Chris, we have a wonderful comment from someone. I'll put it on the screen. This is Kenny.
Yeah, hi, Kenny. I remember you well.
Kenny, yeah, Chris is incredible, isn't he, Kenny? I've learned so much from him. Thank you, Chris, for everything you've done for me over the years.
Oh, thank you. Yeah, thanks, Kenny. Good to see you again.
So, Chris, we've got a ton of people joining us today, and if I may just say, from all over the world, like Malaysia, Nigeria, India, Jordan, Colombia, Saudi Arabia, Maryland, Egypt. So thank you, everyone, for tuning in. If you have any questions, do put it in the chat for Chris. Maybe
it looks like some people didn't see it clearly. That's a bit of disappointing.
Yeah, well, there were a couple of people. I'm not sure it was clear on my end and on Mark's end, so I'm not sure what's causing that. But we'll be posting a replay, which is a good thing to note here. if you do want a replay, if you go to rcmcertification.org/subscribe, if you're not already subscribed, if you go to that URL and put your name and email address in, probably I have to download the video and render it, but by tomorrow I can email you a replay. So if it was blurry, no worries. You can go back over it again for sure.
Was it the sight or the sound people couldn't pick up, or was it both? Was it a visual thing?
It looked like it was a visual thing.
Okay.
Oh, and we have someone from Oman in the house. Okay.
A lovely country, Oman, one of my
Muntasser.
favorites. Yeah.
Oh, you visited, Chris?
Mm-hmm.
Oh, I would love to visit. Well, let me share let me share the website in case any of you might be interested. Let me show you this. Okay, here we go. Okay, so the reason why, as a team, we started RCM certification is because reliability-centered maintenance often gets a bad rap, often because it's not done properly or it's misunderstood. But, you know, it can be done relatively quickly and efficiently when it's done with the right people and when the process is carried out correctly. So RCMcertification.org, and we as the IRCC, we're dedicated to implementing RCM properly so that you can get the results you need, like what Chris showed you. When it's done the right way, the results can be overwhelmingly positive. So if you are interested in RCM certification, all you have to do is go to rcmcertification.org and just click on this blue button. And when you do, you just enter your details and you will have access to the exam. It is a 30-minute exam there are 30 questions. They're all multiple choice. They're all straightforward questions. There are none designed to, trick you or anything like that. But the intent is for you to gain your RCM certification so that you can show that you understand the basic principles of reliability-centered maintenance. Do you guys have anything else to add about RCM certification? Or if you have any questions, do put it in the chat.
Yeah, I actually, Nancy, there's just one thing I'd say, and that is, it's something we've said quite a few times. When you take this exam, I know it doesn't tell you this before you start, but please don't think that we're trying to trick you. There aren't any trick questions in here. They really are just testing that you know about RCM. So we don't ask you something really difficult and then you think, well, this looks too easy, so it must be really difficult. So I'll give one of the answers that I'm not expecting. That it isn't that sort of test at all. And we're trying to find out what you know about RCM to JA 1011 and 1012. So it really breaks our hearts when we see people who've answered questions, sometimes maybe even not passed the exam. We know they knew the answer because it was a really simple question. Just thought it was too simple, so they gave an answer that looked more complicated. It really isn't like that.
Mm-hmm.
Definitely. Thank you, Mark. Chris, we've got a question for you from Hani. Let's see. He wants to know, what is the time period for any RCM project to be completed? Suppose let me put it on the screen. Hold on, so then everyone can see it. Suppose we have identified one critical asset. We started the RCM procedures. For how long should it take to be able to identify what tasks must be taken? Excellent question, Hani. Thank you.
Okay, so I hate to answer by saying it depends, but it does depend to some extent. So one thing that would determine how long an analysis takes is complexity, and RCM is quite flexible because it allows you to analyze things that are quite small and very large. And obviously, the bigger something is, and particularly the more complex it is, the more failure modes you're likely to have, and therefore the longer the analysis is going to take. So that's a big factor. I would say that sometimes people do it inefficiently, particularly with that if they're not experienced. And it is possible to occasionally to put failure modes at a level or a root cause that is a bit higher, depending on how you manage them. And so, you know, it's quite. If you remember back to the presentation, that the competitor that whose analysis I showed had actually, for a similar sort of asset, had done 3 times as many failure modes as we'd done in our study, because he'd done it inefficiently. So sometimes people do it inefficiently as well. But so it's basically, you know, how many failure modes you have will influence how long it's going to take, and then of course it also depends on whether you do the study full time. You know, Mowbray used to talk about 3-hour meetings. In many cases, I don't know about you other guys, but when I do studies, if I have to fly somewhere to go and do a project, I can't fly halfway across the world for a 3-hour meeting, then come back again. So you work full time, and obviously, if you work full time, it's going to take less calendar time than if you have 3-hour meetings twice a week. So. But you know, quite typically, to give you an answer, quite often I would do a pretty substantial piece of equipment within 5 days. If I've got also you need a good team as well. You need a good team of people that know the asset best. Otherwise, you end up speculating and you end up wasting time. So I can't give you an exact answer, but it depends on the type of equipment. But I think Honey, you might have tried to connect with me. If you want to discuss this further through LinkedIn, if you have connected to me, I'm quite happy to continue that conversation with more specifics, if that helps. Okay.
Okay, we've got another question from Ala. He wants to know, do we need to read the RCM related standard to pass the exam? Mark, maybe would you like to field that one?
Yeah. Any background you've got in RCM is going to help. But certainly for level 1, I'd say, provided that you know what's in JA 1011 particularly, and JA 1012, then that should be enough. And it's a really good question, because it's great to have a bit more breadth than that, and certainly reading John Mowbray's original RCM2 book would be fantastic as well. That'll give you the kind of rounding you need as well. I wouldn't say necessarily that the ISO standard would help a great deal towards the level 1 exam. So don't go out of your way to review that, because there's nothing specific that would be related to it. JA 1011, 1012, a good grounding in introductory RCM, that should get you through easily.
Great, thank you. Okay, any other questions, definitely do put them in the chat. And if you are not already subscribed, please do so, because we're going to be coming live again. And if you're subscribed, we'll let you know. Okay, Hani has another question. Any recommended metrics to measure?
Are you talking there, Honey, about KPIs or?
Maybe you could get a little more specific with your question, Hani.
Yeah, I guess one of the things it might be useful to know is whether we're talking about equipment measures, or whether we're talking measures about the RCM analysis and how well you're doing with it. I don't know which it would be here.
But in terms of KPIs, you can do an RCM analysis for all sorts of reasons. Obviously, you've got reliability, you've got cost as well, safety, a lot of those KPIs. And Mowbray always said that if you're doing an analysis, or if you want to discuss with a client where you're doing an analysis and why you're doing analysis, you'd ask where they're feeling pain. He spoke about pain. Where is there the biggest gap between the performance you want from the assets and the performance you're getting from the asset by whatever measure that matters to your business? But there's a few pretty standard universal KPIs, I think, for whatever the business is, aren't there? Things like the cost and reliability and safety and lost time incidents and environmental outages and things like that can all be addressed through the proper application of RCM. Thank you, Hani. Thank you for your questions.
Did.
That's fine.
Yep. Okay, I was muted there. Okay. Let's see. I don't know. There are no more questions in the chat at the moment. Does Mark, Graham, or Chris, any last thoughts?
I guess, well, Chris has covered it really well here, and I suppose the only thing that we could get into at some future point is the implementation side. I didn't really want to go there in this because it's a whole subject by itself. But the fact that you're doing more than just maintenance obviously means that you're implementing in a lot of different places. You're implementing physical redesigns, you're implementing procedural changes. And that is can be such a can of worms. I think possibly we ought to have a future live session on it. So let's book ourselves for that at some point.
Yeah, good question, Mark. Good point, Mark. Yeah, it does make things more difficult, doesn't it? And you need to involve other people then, because you've got projects and you've got design and you've got everything like that. And maybe it's a little bit cleaner if you just stick to maintenance.
Yeah, it's tempting.
I'd love that idea for our next live, Mark. So maybe as a team we can discuss that, and if you're subscribed, we'll email you and let you know when that one will be coming. Well, thank you everyone for joining us from all over the world. Thank you for your time, and thank you, Chris, Mark, and Graham. And we will most definitely see you guys soon. Bye-bye, everyone.
Cheers. Thank you.
Thanks.